This video is meant for Mrs. Rose's AB calculus class, and it is on inverse functions derivatives. Alright, if you're following along with our inverse function exploration, what I'd like you to do is fill in this chart with the y values of the function f of x equals x squared for these x values, and also take the derivative, fill in these slope values, and then do the same thing for this inverse function. Press pause to complete this chart. Press play when you're ready to move forward. Okay, here's this chart completed, and now what we're going to do is make some observations based on what we've filled in. If we look at the y values of f of x and the x values of f to the negative 1, or the inverse function, we can see that these values are exactly the same. So if we have the point AB on the graph of f of x, what is the point on the graph of the inverse? For example, we can look at 3, 9 and 9, 3. So if we have the point AB, just like these two points, the x and y value are going to be switched. Finding the slope of an inverse isn't that hard, especially if you know what the inverse function is. We're just going to plug it into the derivative, which is 1 over 2 square root of x, and that means that this is going to be 1/8. Now the relationship between the slopes of the function and its inverse, if we have, if we look at the slopes, we get 2 1/2, 4 1/4, 6 1/6, 1 and 1, 1/5 and 5. We can see that the slopes are going to be reciprocals. If that is always true, then this theorem, the inverse function theorem, will always hold to be true. So when we are going to calculate the derivative of an inverse, if we're not given the inverse, we're going to focus on the original function that's given. So the first thing we have to do is figure out what is the x value when the y value is 8. We know that we need f of 2 to equal 8. And that's important because we know that the point 2, 8 is on f of x, and we know that the point 8, 2 is on the inverse function. Then we're going to take the derivative of the original. The derivative of x cubed is just 3x squared. Now using this theorem, we can say that the derivative of the inverse at 8 equals 1 over the derivative of the original at 2. So 1 over 2 squared, 3 times 2 squared. 2 squared is 4, 4 times 3 is 12, so this is 1/12. For number 3, again, this is the y value for the original, and it's the x value for the inverse. So we're trying to figure out what angle will give us the square root of 2 over 2. And on the interval from 0 to pi over 2, the sine of pi over 4 gives us square root 2 over 2. Then we're going to take the derivative of sine x. The derivative of sine x is cosine x. So when we answer this question, we're going to do 1 over the derivative of the original at pi over 4, so 1 over cosine of pi over 4, which is 1 over the square root 2 over 2. And when you take the reciprocal and then rationalize by the denominator, the answer is square root of 2. Then we get to functions that are a little bit more difficult. We still want to figure out what's the x value for this y value, and for that we're going to use our graphing calculator. So you're going to graph x cubed plus x plus 1 and the y value 4. This is following along with the example at the top of the back page of the worksheet. When you graph this, you get these two curves, and we want to find the point of intersection. So I'm going to go to second trace, phi, which is intersect, and I'm going to move it to the left on my first curve, move it to the right on my second curve, and give it a guess. So this x value is going to be what I write down on my for my x value over here. So we got 1.2134117. Now we're going to take the derivative of our original function. Not too bad. F prime of x equals 3x squared plus 1. Now we know, using that theorem that we just learned, that the derivative of the inverse at 4 is going to equal 1 over the derivative of the original at that x value that we found. So this is going to be 1 over 3 times that x value squared plus 1. And that's simple enough to find. We can go to our computer screen and do 1.2134117 and store that as x, and do 3x squared plus 1. And we get the 5.417, etc., etc. Now what we want is 1 over that, so over here I'm going to do 1 divided by my answer to get this value. And then you can round to 3 decimal places to get 0.185. Okay, these we're going to do very, very similarly. We're going to graph x cubed plus 9x minus 2 and the line y equals 5. I'm going to try it with the inspire this time. So here I got my first function, and then I'm going to graph my second function by pressing Control G and then 5. And I want this intersection point. Oh, my computer froze just a little bit. Alright, so we're going to go to Menu, Analyze Graph, Intersection, Lower Bound, Upper Bound, and we get this value. So, over here, we are going to say that the x value is 0.733864. To find the derivative, we can go to our calculator screen and we're going to type in 0.733864 and store that value as x. And then we're going to plug in 3x squared plus 9, get that, and then we want 1 divided by our answer. So our final answer for this problem is going to be, what did I say it was, 0.094. Okay, these are all incredibly similar. If you go through, again, we're graphing this, graphing the y value 7, and find where it intersects. Should get that value. And that's easy enough to check, so we're going to graph those two functions. And we want to find the intersection point, so I'm going to go second trace for 5. Our first curve, we're going to go a little bit to the left of that intersection. Our right curve, our second curve a little bit to the right of that intersection. And we get 3.8097834. To figure out the derivative, I'm going to do 3.80978, store as x, and then I'm going to take the derivative 2 plus cosine x, and then do 1 divided by my answer. And over here, we should get the 0.823. On number 6, we want to graph this function and 2. Okay, here's the function, and then I'm going to graph my y value, and I want the intersection. Oh, froze a little bit. There we go. And so we are going to go and write that in as our value over here. And then I'm going to store that number, 2.3593, store as x. And then I'm going to type in the derivative. Okay, so I'm going to do the quotient rule, and I've got 3x squared, oops, it's going squared, just kidding, squared, times okay, enter that, and then we want 1 divided by the answer. Oops, I made a mistake. There's the correct derivative. Press enter, and then we've got 1 divided by the answer. There we go. So our derivative is 0.904. And then last but not least, we're going to graph this one on the TI-84. And we got graph. And this is for x greater than 0, so we're only interested in this intersection. So we got second trace 5, and we want to make sure we're to the right of 0. So we got enter, just a little bit more to the right, enter, enter. And here's our x value. Okay, and then we are going to enter that x value. Oops, this is supposed to be an 8. 497, store as x. And then we want the derivative. Got that, and then we want 1 divided by the answer. So our answer over here is going to be negative 0.1701. And then over here, G is the inverse of F. So here's F, and we want the inverse of 4. So the derivative is going to be the reciprocal of 1/4. And so that's going to be 4. And then G prime of negative 1 is going to be the reciprocal of 2/3. And we've got over here, f of 2 is negative 3, f prime of 2 is 2/4, G is an inverse of f. So we're going to need to go backwards. So G of negative 3 is going to be 2, and G prime of negative 3 is going to be the reciprocal. And our equation of the tangent line is going to be y minus 2 times the slope times x plus 3. And if we work it out, we're going to get y equals 4/3 x plus 6. Hopefully this helps you answer your day 3 homework questions. And if you need any more help, please come see me in Cav morning or after school, or ask me during class.